previous lesson, we already learned on how to classify our relative extremum by using first derivative test. So now we will proceed to the next part where we have to find relative extremum by using second derivative test. So for second derivative test, basically we will identify the relative extremum based on our second derivative equation. So first step will be the same, where we have to find the critical points or critical number. After that, we substitute value of x into our second derivative equation. If our result of second derivative is greater than 0, means that we will have a relative minimum. If our second derivative result is less than 0, means that we will have relative maximum. And if our second derivative result is equal to 0, means that the test is inconclusive, thus we have to use the first derivative test. We also have 5 main steps for the second derivative test. So for the first step, we have to find the critical number. After that, we find the coordinate of y. Then we will find the second derivative. After that, we determine their nature by substitute our critical number into the second derivative equation. And after that, we can make the conclusion. So let's do some exercises. Example 5, we have to find the relative extremum by using the second derivative test. Our equation for this part A, we have fx equal to 4 plus 12x minus 3x squared minus 2x cubed. First step, we have to find the critical number. So we don't have any other choice but to differentiate our fx equation. And in this case, we just have to use basic rule. So our f prime would be equal to 12 minus 6x minus 6x squared. Next, in order to identify the critical number, we have to equate our f prime equal to 0. So equating this quadratic equation, in order to find the value of x, you just have to factorize by using calculator. From there, you will get the result of x equal to negative 2 and x equal to 1. So these two would be our critical number. Settle with our first step. Moving on, our second step is basically we have to find our y value. In other words, we want to determine the coordinate. So first, when our x is equal to negative 2, we substitute this into our original equation. Bear in mind, we only substitute this into our original equation. So substitute x equal to negative 2, we will get y equal to negative 16. This means that the coordinate for the first one will be negative 2, negative 16. Now, repeat the same process for x equal to 1. So, substitute x equal to 1 into our original equation. We will get value of y would be equal to 11. So, the coordinate would be 1, 11. And that is it for our second step. Now, we already obtained these two coordinates. So, we want to identify whether these minimum point or maximum point by using second derivative test. So our first derivative test is 12 minus 6x minus 6x squared. Now in order to use second derivative test, we have to find the second derivative equation, or f double prime of x. Means that we have to differentiate our first derivative equation. In this case, we will get negative 6 minus 12x. Now, in order to identify the nature of our critical number, we just have to substitute this into our f double prime equation. So the first one, when our x is equal to negative 2, substitute this into f double prime, we will get a positive result. For positive result means we get a happy result with a smile face. Means that we're going to have a point at the bottom of our curve. So from here we can conclude that the coordinate of -2, -16 is minimum point. Proceed with the second one. When our x equal to 1, substitute this into our f double prime equation, we will get a negative result, means we get a sad result. From here we can see that we will have a point at the top of our curve. From here we can conclude that our point 111 is maximum point. And this is basically how you determine the relative extremum by using second derivative test. Let's do another example. So question B, we have our fx equal to x to the power of 4 minus 2x squared plus 1. So step number 1, same as before, we have to differentiate this equation. So from here, our f prime is 4x cubed minus 4x. Next, in order to find the critical number, we have to equate this equal to 0. So if we equate 4x cubed minus 4x equal to 0, we can factorize this out and we will get 3 values of x, which are 0, -1 and 1. So from here, we have to find the y value for each of these x, means we have to find the coordinate of it. So the first one, when our x is equal to 0, substitute this into our original equation of fx, we will get y equal to 1, means that the coordinate would be 0, 1. Next one, for the second value of x equal to x equal to 1, substitute this into y equation, we will get y equal to 0, means that the coordinate will be 1, 0. And last one, when our x is equal to -1, substitute this into y equation, we will get value of y equal to 0, means our coordinate is -1, 0. So from here, we already have 3 points. Now, using second derivative test, we want to classify these 3 points. So, we have to find our second derivative equation first. So, differentiate our first derivative, we will get 12x squared minus 4 as our f double prime x equation. Now, you just have to directly substitute value of x into our second derivative equation. Start with the first one. When our x equal to 0, substitute this into f double prime, we will get a negative result. So, a sad result means that we're gonna have a maximum point. So, from here, our conclusion, 0, 1 is a maximum point. Second one, when our x equal to 1, substitute this into our f double prime equation, we will get a positive result, means that we have a positive phase result. So from here, we can conclude that 1, 0 is minimum point. And last one, when our x is equal to -1, substitute this once again into our f double prime equation, we will get a positive result, means we're gonna get a happy result there. Once again, -1, 0 will be minimum point. And this is how basically you determine the relative extremum by using second derivative test.